So I downloaded this AI Workbench AI Workbench from NVIDIA, and the whole idea really is so you can run CUDA machine learning and stuff on your local machine. All other samples are way too big to run on your desktop. They all require like 30 gig of video memory, but you can still do all kinds of interesting, use it as an AI Workbench, not just for LLMs, large language models. And so they have the ability, basically, it's pretty interesting. You have the ability to start a project on your local machine or start a project on your remote machine. I actually have a Linux server sitting in the other room. And so, the question was, how does it talk to your machine and the remote machine? And I ran the Windows installer, and it turns out it's a moderately sophisticated environment, and it makes the local machine look like the remote. So even though you're on Windows, it actually is a completely Dockerized environment. So this is mostly accurate from my sleuthing around. So on your Windows machine, you install AI Workbench, which was the UI you just saw. You install Docker Desktop or Podman. It requires that, and you have a web browser. And then what that does is it actually creates a WSL, Windows Subsystem for Linux, NVIDIA Workbench instance that it actually runs AI Workbench on, and it talks to it over port 10,001 is what it looks like on my machine. And so all of the WSL, really the tools that do all the work, like the Docker building, it actually, this is a containerized environment. So when you create a new project, it actually builds a new container for you. And all of your projects run each runs inside their own isolated container, which is really cool. All that work is actually done on the NVIDIA at least as near as I can tell, all that work's actually done on the NVIDIA Workbench WSL. So basically it treats it like a Linux machine server kind of thing. And then whenever you actually deploy a workspace, whenever you try and open a Jupyter notebook or you make a working project, it actually talks, obviously, in Windows, it talks to Docker Desktop. And so that all actually runs in the Docker Desktop VM, right? So WSL instance, really. So you have two VMs, which are WSL instance. One's for the Workbench itself and one's for Docker Desktop. And when you spin up a project, it creates a container, an image, and then it remotely from the Workbench tells Docker Desktop to deploy that image that was created or into a container, right? Becomes a container, and then you can run your project. And typically, because of the way it does this disconnected kind of, it's not your local file system, really they want you to put all your projects out on GitHub or some Git project somewhere, right? And that could be a private or a public repo. In my case, it's public because I don't pay for private. And so that's how that works. Now, on my Z820, which is a really old server desktop machine, like a 20-core, 40 virtual cores, that thing also has Docker running on it. And so what you do is you actually do a command line install of the Workbench server on that machine, and the Windows host actually, or the Windows, your desktop environment actually does an SSH over to that to do all the commands, and then it deploys all the stuff in Docker. And then again, you connect with your browser. So in my case, if I connect to something on my Windows machine, I can connect on port 10,000. And if I connect to something on my Z820 on my server, a Linux server, it actually connects over 10,000 too. So that's really the thing to think about. All the home directories, when you actually create a project in Studio, I'll show you in a minute, it's actually creating it either in that NVIDIA Workbench machine and then making that visible to the container, or it's creating it on the Linux server. So really none of that ends up on your Windows machine when you use AI Workbench. So let me just pull it up and show you. So in this case, I could do this remote. I don't know if that server's up. You know what? 4 minutes. Okay, I'm gonna create a project. So basically I'm gonna create a template here. Now we'll just call it my project. You know what? Why not? We'll just and I'll clean it up later. And what it's going to do is it's going to ask me which runtime I want. In my case, I really would like to do some CUDA work, but you know what? I don't know how to do that, right? Well, I have a project. You know what? Never mind. We're going to just do Python basic here. And then I create it. And you can see here down in the bottom, there's actually a terminal window that shows you that it went out. Because I've already done it on this machine. It goes down and creates a Docker image for this, and it downloads all the parts, and you can tell it runs a Docker file, right? And so now I actually have, man, the one thing I don't like on this program is, so down here you can see the status, right? Uploads, apps running, build ready, build's done. So what I'm going to do, I can actually start this Jupyter notebook. Man, you know, I really don't like that. Anyway, and what will happen is it will actually start that in the Docker container, and then it'll open up the web browser. So it's spinning up the Docker container at this point, and that'll take a second, and there we go. And so that's the Jupyter notebook with that template project with no code in it that I just spun up. So that's what we did in what, like a minute? I was able to spin up let me go back to the browser. You can, whenever you make changes in here, if you've bound this to a Git repo, it will automatically show in this user interface that you have changes to commit, and it'll publish them. It's kind of a coarse grain interface, and so sometimes I'll jack into the, you know, maybe want to put a Git plugin in the Jupyter notebook or something. But anyway, this works, right? So that was less than a minute, created a Docker container, created a Python project, and uploaded it.